Hey there, science fans! Welcome to an incredible journey into the unseen world that exists all around us. Have you ever wondered what makes up everything around you? From the chair you're sitting on to the stars in the sky, everything is made of tiny particles. I'm talking about the air you breathe, the water you drink, even you and me. Every single thing is composed of these minuscule building blocks. Well, get ready to shrink down to the atomic level because we're about to explore the amazing world of atoms. Imagine diving into a world so small it's invisible to the naked eye. Atoms are the fundamental building blocks of matter, so tiny you need a super-powered microscope to see them. These tiny particles are the foundation of everything in the universe. Think of them as the Legos of the universe. Just like you can build anything with Legos, atoms can combine in countless ways to form all the substances we see and use every day. Just like Legos can be combined in countless ways to build anything you can imagine, atoms combine to create the incredible diversity of our world. From the simplest molecule to the most complex structures, it's all about how these atoms come together. In this wild ride, we'll discover the particles that make up atoms, how they're organized, and even how scientists keep track of them. We'll delve into the fascinating world of protons, neutrons, and electrons. We'll also explore the amazing patterns that emerge in the periodic table and how these patterns help us understand the behavior of elements. The periodic table is like a map that guides us through the atomic landscape. So buckle up and get ready to explore the universe within. This journey will take us through the very fabric of reality, revealing the secrets of the atomic world. It's going to be an atomic adventure. Prepare to be amazed by the wonders that lie within the tiny universe of atoms. Every atom, no matter how big or small, has a nucleus at its core. The nucleus is like the sun in our solar system, and it's made up of two types of particles, protons and neutrons. Protons have a positive charge, kind of like tiny magnets with a plus sign. Neutrons, on the other hand, have no charge. They're neutral, just like their name suggests. Whizzing around the nucleus like planets orbiting the sun are electrons. These tiny particles have a negative charge and are attracted to the positive charge of the protons in the nucleus. This attraction is what keeps the atom together, just like gravity keeps the planets in orbit around the sun. The number of protons in an atom determines what element it is. For example, all carbon atoms have 6 protons, while all oxygen atoms have 8. This number is called the atomic number, and it's like the atom's fingerprint. Now imagine trying to keep track of all the over 100 known elements. That's where the periodic table comes in handy. It's like a giant organized chart of all the known elements, arranged by their atomic number and properties. Think of the periodic table as a giant apartment building for elements. Each element gets its own apartment, or box, with its name, symbol, atomic number, and atomic mass. The elements are arranged in rows and columns based on their properties, like how many electrons are in their outer shell. Elements in the same column, called a group, tend to have similar chemical properties. For example, the far right column contains the noble gases, which are all very unreactive. The periodic table is a powerful tool for chemists, because it allows them to predict how elements will behave and interact with each other. Section 4. Moles, counting the uncountable. Atoms are so small that even a tiny speck of dust contains billions upon billions of them. Trying to count individual atoms would be like trying to count all the grains of sand on all the beaches in the world. That's where the mole comes in. A mole is simply a unit of measurement, just like a dozen means 12. But instead of 12, a mole is a huge number 6.022 times 10 to the 23rd. That's 602 sextillion, or a 6 followed by 23 zeros. Think of it this way. If you had a mole of donuts, you could give every person on Earth over 7 billion donuts each. That's a lot of donuts. Section 5. Molar mass, weighing in on elements. Now that we can count atoms using moles, how do we measure their mass? This is a fundamental question in chemistry because understanding the mass of atoms and molecules helps us grasp the scale of chemical reactions and processes. That's where molar mass comes in. Molar mass bridges the gap between the microscopic world of atoms and the macroscopic world we can measure. Molar mass is the mass of 1 mole of a substance, usually expressed in grams. This allows chemists to weigh out amounts of substances that contain a specific number of atoms or molecules. It's like the weight of that giant pile of donuts we talked about. Imagine having a pile of donuts so large that it represents a mole of donuts. The concept is similar but applied to atoms and molecules. Each element has its own unique molar mass, which you can find on the periodic table. This table is a treasure trove of information providing the molar masses of all known elements. For example, the molar mass of carbon is 12.011 grams per mole. This specific value is crucial for calculations in both academic and practical chemistry. This means that if you have 12.011 grams of carbon, you have 1 mole, or 6.022 times 10 to the 23rd atoms, of carbon. This number, known as Avogadro's number, is a fundamental constant in chemistry. Molar mass is a really useful concept in chemistry because it allows us to convert between the mass of a substance and the number of atoms or molecules it contains. This conversion is essential for understanding and predicting the outcomes of chemical reactions. It's like having a secret code to unlock the secrets of the atomic world. With molar mass, we can decode the quantities of substances involved in reactions, making it an indispensable tool for chemists. Section 6. Periodic Trends Uncovering Patterns in the Elements. The periodic table isn't just a list, it's organized to reveal trends in element properties. These trends help scientists predict the behavior of elements and understand their relationships with one another. One trend is atomic radius, which is like the size of an atom. The atomic radius can tell us a lot about how atoms will interact with each other. As you move down a group, atomic radius increases because you're adding more electron shells, kind of like adding layers to a cake. Each new layer makes the atom larger and changes how it interacts with other atoms. Another trend is ionization energy, which is the energy required to remove an electron from an atom. This energy is crucial for understanding chemical reactions and bonding. Think of it like how much effort it takes to pull a magnet off the fridge. The stronger the attraction, the more energy you need. Ionization energy generally increases as you move across a period because the electrons are more attracted to the nucleus. This increased attraction makes it harder to remove an electron. Electronegativity is a measure of an atom's ability to attract electrons in a chemical bond. This property is essential for predicting how atoms will bond and form molecules. It's like how much one atom wants to hog the electrons in a bond. The more electronegative an atom, the more it pulls electrons towards itself. Electronegativity generally increases as you move across a period and decreases as you move down a group. Understanding these trends helps chemists predict how different elements will react and combine to form new substances. Section 7. Atoms in Action, from your phone to the stars. Atoms and their properties are not just abstract concepts found in textbooks. They are the very essence of our technological world and the vast universe beyond. The vibrant colors on your smartphone screen are a result of carefully controlled electron transitions within atoms. The life-giving energy from the sun comes from nuclear fusion reactions, where atoms fuse together to release immense amounts of energy. From the food we eat to the air we breathe, our world is built upon the interactions of atoms and molecules. Understanding atomic structure and properties allows us to design new materials, develop life-saving medicines, and explore the mysteries of the cosmos. So there you have it, a glimpse into the amazing world of atoms. Keep exploring, keep asking questions, and never stop being curious about the science that surrounds you.